Hi everyone, it's Ms. Barber here with the second part of lesson 5.4 in Algebra 2, completing the square. So in 5.1, we talked about how to use the square roots property to solve. There's another way to solve using completing the square. So for the warm-up, these are just reusing the square roots property. So you can review lesson 5.4 part 1 if you need help, but let's go over part C together. So in letter C, I have a perfect square trinomial here on my left, x squared plus 8x plus 16. So if I was to draw my x to factor, my a times c is 16, my b is 8. I have ax, which is just 1x on the top. Two numbers that multiply to 16 that add to 8 are 4 and 4. So this is a perfect square trinomial, so I'm going to get x plus 4, quantity squared, equals 49. And then again, now we have a square, so we have to undo it by square rooting. Square and the square root cancel. I'm left with x plus 4 equals plus or minus 7, the square root of 49. So to solve, I can subtract 4 from both sides. So x is equal to negative 4 plus or minus 7. And remember, we can actually do that. Negative 4 plus 7 would be positive 3. Negative 4 minus 7 would be negative 11. So those are your two answers by solving using the square roots property. Remember, solutions to quadratic equations can be called also roots or factors. So you'll see lots of different words that all mean the same thing. They also can be called zeros. Excuse me. So sometimes our quadratic equations are not factorable, and we can't just square root both sides. So we can do a thing called completing the square. That's going to turn quadratics into perfect square trinomials. So in part C there, my left-hand side of the equation was a perfect square trinomial. It's always going to have the pattern of x squared plus 2 times c plus c squared. So notice my c here, 16, the square root of 16 up here in my original was 4, times that by 2, and that's how you're going to get 8. So it wants us to factor that trinomial, well, we just did up top, and that's going to be x plus 4 quantity squared. So that's a perfect square trinomial. And that's going to be important because when we complete the square, we're going to be ending up with perfect square trinomials each time. So here are the steps for solving by completing the square. You first have to divide your entire equation by a so that the coefficient in front of x squared equals 1. So you don't want anything in front of x squared other than 1. You're going to move c then to the other side of the equation. So you're going to get something that looks like this. S squared plus bx equals c. We're going to typically leave some space here and here, and you'll see why in a minute. Now when you start to figure out what your c has to be in order to fill the yellow spot in there to create a perfect square trinomial, you're actually going to draw your x and put b in the bottom, so like how we do when we factor. Then you're going to come up with two numbers that add to b that are going to be the same number. And it'll be more obvious when we do it. But effectively, you're dividing b by 2, and you're writing that on either side of your x. You're going to find your c, which is the top of your x, by adding the two numbers together. And you're going to add that result to both sides of the equation. So therefore, you just completed the square. Then you're going to factor the equation, and it should be quite easy. You already have your x with all the numbers properly in it to factor. Then you should have a perfect square trinomial. It should look something like number c. You can take the square root and solve. So let's start here in example 1 just by completing the square. So we're not going to be solving. There's no equal sign. We're just finding out what our c is. So we're going to start by drawing our x. I don't know what my c is, so I'm going to leave the top of my x blank. But my b is 4, so I'm going to put 4 in the bottom. How this is going to work is I have ax, so I'm going to have two x on the top here, x on the top here. And I want the same number on the bottom of my fraction on the left and right. Well, the same number that adds to 4 is 2 and 2. So then to find C, I'm going to multiply 2 times 2, which is 4. So C is my term that I'm trying to use to complete the square. So that's what goes in my box. That's 4. If I was to factor it, it would just be x plus 2 going off of my x here squared. So it's going to work the same thing for letter B. Draw your x. Negative 8 goes on bottom. My a is still 1, so x and x on top. Two numbers that add to negative 8 that are the same would be negative 4 and negative 4. Multiplying those together at the top would be positive 16. So that's your C that completes the square to make a perfect square trinomial of x minus 4 quantity squared. Now letter C, you might think, oh no, I don't like this because my B, 3, is not divisible by 2. Well, we can still do it. What two numbers add to 3 that are the same? Well, that's just 1.5. So you can get fractions or decimals for this. That's okay. It shouldn't be an issue. 1.5 times 1.5 will still be my C, so that's 2.25. So that's my C, and when I factor it, I get x plus 1.5 quantity squared. That's completing the square. So now let's do this while applying it to some problems. So turning the page in example 2, I set up some of them nicely for you, and then other ones I did not. So let's go ahead and try number 1. So number 1, you'll see I left the C blank for both. So using just the left side, like we did in example 1, I'm going to draw my x. My a is 1, my b is 6, so that's going to go on the bottom, and I don't know what my c is. That's what I'm trying to find. I can set up 1x on top. Two numbers that add to 6 that are the same will be 3 and 3. 3 times 3 is 9, so that will be my c. Because this is now an equation, whatever I add to the left side, I'm also going to have to add to the right side. So if I add 9 to the left to make a perfect square trinomial on the left, I have to on the right. My left is now going to factor 2x plus 3 quantity squared. Again, we can see from our x, that's where it came from, equals 7 plus 9 is 16. Now I have an equation that looks a lot like the warm-up in letter C, or what we did yesterday. So to solve, I can take the square root of both sides. I'm left with x plus 3 equals plus or minus 4. Subtract 3 from both sides. So x equals negative 3 plus or minus 4. Again, I can actually find out what these numbers are. Negative 3 plus 4 is positive 1. Negative 3 minus 4 is negative 7. So those are your two answers for x, solving this equation. Number 2 is going to be the exact same thing, so pause the video, see if you can follow these same steps for number 2. Let's look at number 3. Number 3, notice there is a term now that's not 1. I have this 2 out in front. Well, you might be thinking that's no good, and it isn't. So what we're going to have to do is we're going to have to divide everything by 2. Dividing everything by 2, I'm going to get d squared, with the 2 out in front, d squared minus 5d, plus, we're still going to leave that blank, equals, oops, sorry, you didn't want to divide that by 2, equals 8 plus something. Now let's draw my x. Negative 5 is my b that goes on bottom. The two numbers that are going to add to negative 5 are going to be negative 2.5. Sorry, my handwriting's bad. And negative 2.5. Multiplying negative 2.5 by negative 2.5, I'm going to get positive 6.25 in the top. So that's my c I have to add to both sides. Now you have to be careful because I'm adding 6.25 here as my c. But really it's not just 6.25. It's going to be 2 times 6.25 on my other side because I still have that 2 out in front. So I'm going to do 6.25 times 2, and that's 12.5. So that's going to be what's on my right. Now continuing to solve, I'm going to have this 2 out in front, and then my perfect square trinomial is going to be d minus 2.5 quantity squared equals 12.5 plus 8 is 20.5. I have this 2 out in front that I need to now divide out, so I'm going to divide both sides by 2. When I do that, I get d minus 2.5 quantity squared equals 10.25. And now I'm going to take the square root. So taking the square root, I'm going to have d minus 2.5 equals the square root of 10.25. So this is now where you can decide, do you actually just want to get the number? Do you want to leave it in square root? This is a decimal, so we might as well just get the number and not leave it in the square root because it's not a pretty square root to begin with. So it's going to be plus or minus 3.2. That's the square root of 10.5. Last step, you're just going to add 2.5 to both sides, and then you can use your calculator to find that answer. So that's how you solve it when you have a term. You have to divide it out like a GCF. So there's a few extra ones here to practice. A lot of them are not set up for you anymore. So let's just quickly look at number 6 because this one is not set up. So let's make sure we know how to set it up. For number 6, remember you want your b to be on the same side as your a. So moving the 12x to the left, I'm going to end up with 4x squared plus 12x equals 4. I have an a term that I need to get rid of, so I can divide it out. And this time we can divide everything by 4, so this is another method, is divide everything by your GCF and then it goes away. And I'm left with x squared plus 3x equals 1. I'm going to leave some space here and here for my b, or my c, sorry, my letter C. I'm going to draw my x. My b of 3 goes on bottom. And again, this is 1.5 and 1.5. We already did this in example 2, I believe, or example 1. X and x. So my c is going to be 2.25. So I have to add 2.25 to both sides. And then you're going to continue to factor, square root, simplify, and solve. So that's how you solve equations, by completing the square. It's not always the most effective method, and it's not the fastest, so it's not usually what we choose. One reason to complete the square is because you can write then quadratic equations in vertex form. So you may or may not recall from lesson 5.2, vertex form is going to be f of x equals a parenthesis x minus h quantity squared plus k. So that's vertex form. So you'll notice the x minus h term, that's like a perfect square trinomial with your plus c as the plus k added on at the end. You don't have to complete this square in order to write a quadratic function in vertex form. You could, and if you want to do it that way, you're more than welcome to. However, that's not actually the quickest way. The quickest way is to do it exactly like how we did it in lesson 5.2 when we had something in standard form and wanted to convert it to vertex form. So you might recall how we find h is opposite of b divided by 2a. And then to find your k, you're going to take your h and substitute it in for your x's to solve for y, or your f of x, or whatever you want to call your function. So that's actually how you do it. So you could just use that formula each time, which I recommend because it is the most simple way. So if you let, in this case, a is 1, b is 24, and c is 145. So your h is going to be opposite of b over 2a, so negative 24 over 2 times 1. So that's going to be negative 12. That's your h. Your k, you're going to substitute negative 12 into your original function. So negative 12 squared plus 24 times negative 12 plus 145. When you do that, you're going to get 577. So now I have everything I need, because you need three things in order to write something in vertex form. You need your A, which I have, you need your H, which I got, and you need your K. So writing this in vertex form, it's going to be f of x equals 1x, or just 1, so I'm not going to write it, x minus negative 12, which is x plus 12, quantity squared, plus 577. So that is one way to write something in vertex form. And again, my vertex would be negative 12, comma, 577. Another way, if you have more friendly numbers. So hopefully you recognize we had 24 and 145 in our equation. It's not going to be a friendly number. Another way is you could literally graph this on your graphing calculator. So if I wanted to graph this on my graphing calculator, which I'll do, so let me find my graphing calculator. So in my y equals, I'm going to clear out what I have, and I'm going to type in 3x squared minus 18x plus 7. And then I'm going to press graph. And right now, because of the way, if I flip my screen around, hopefully you can kind of see, right, that my vertex is going to be at the point 1, 2, 3. So at when x is 3, and then comma, we're not sure. There's actually a way, if you press shift and calc, we're trying to find the minimum value. Now I can't do it on this calculator, but if you choose number 3, minimum, and then go to the left and right, it'll tell you. So you could also just change your window to figure that out. But anyway, when you do that, you're going to get that your vertex is 3, comma, negative 20. So you could just look at your calculator. Doing it that way, I have my vertex. I know my A is 3 from my original. So my answer is going to be g of x equals 3 parenthesis x minus h, so minus 3 squared minus k, which is 20. So that's another way, if you have a graphing calculator, is just look for the vertex on a graphing calculator. So you can try number 9 in whatever method you want, and then check your answer. Last thing is a word problem. Let's look at number 10. Nathan made a triangular pendant for the Band Booster Club. The area of the pendant is 80 square feet. The base of the pendant is 12 feet shorter than the height. What are the lengths of the base and height of the pendant? Well, in geometry, you learned that base times height divided by 2 is the area formula for a triangle. We know that the area is 80 feet. So I could say 80 equals, the base of the pendant is 12 feet shorter than the height. So I don't know what the height is, I'll call it the height. The base is going to be the height minus 12 because it's 12 feet shorter, and I'm dividing by 2. Now I have this equation that I can solve. I see I'm dividing by 2, I want to get rid of that, so I'll multiply both sides by 2. 80 times 2 is 160, so I'm left with 160 equals, I'm going to have to distribute this out, so I'll go ahead and do that now. H squared minus 12h. Hopefully you remember with solving equations that needs to be set equal to 0, so if I move 160 over, I'm left with h squared minus 12h minus 160 equals 0. And now, even though this is in the completing the square portion of the notes, I wouldn't complete the square. Again, you never actually have to. Instead, I would just factor this. You've had plenty of practice. Factor it, set each factor equal to 0, and see what you get for the height and the base. And then you should be able to answer letter B. That's it for the second part of 5.4, completing the square. I know it's a little bit confusing, so Feel free to watch the video again, try some problems on your own, and again, you never have to complete the square. You can always solve with other methods. Tomorrow or the next day, you're going to learn about a new method to solving